So the energy which is available, not available all the time is solar, because daytime you can have solar, but night you cannot perform. But nuclear fission and geothermal does not depend on the surrounding condition. Anytime you can utilize that energy. Question 32. What could be the answer? A woman in a factory has to lift a box onto a shelf. Which action involves the woman doing the least amount of work? Smallest work done. Yeah, D is the right answer.
Yeah, D.
So because work done depends on force and distance, the box is same, so force is same, but the distance, if I decrease the distance, I will do smaller amount of work done. Okay, we'll solve some question now related to this energy topic. Electric motor that drives the lifting mechanism is powered by batteries. State which form of energy stored in the batteries. What is the form
Chemical.
of? So chemical. The lifting mechanism raised the box of mass 32 kilogram through a vertical distance of 2.5 meters. Yeah, chemical is the right answer. In 5.4 seconds, calculate the gravitational potential energy. So formula to calculate the gravitational potential energy or potential energy is,
800 joules.
it will be mgh. So mass is 32, the gravity is 10, and the height to which we move, that's 2.5.
800.
800, so this will be 800 joules. In the second part, the efficiency of the lifting mechanism is 65%. Means it is 65% efficient. Calculate the input power. So this is energy. This is a potential, because what happened if we say something is a lifting mechanism, so it is lifting the object. So useful work done is a potential energy, or useful energy is a potential energy. What we need input power. So the formula for efficiency,
Input divided by output multiplied by 100.
no, opposite, it's output divided
Yeah,
efficiency
output divided by.
is equals to out, but here its power is given. So output, useful output, energy divided by input energy multiplied by 100. That's a formula for efficiency. It can be in terms of power, but because in the previous part I calculated the energy, that's why I wrote this formula in terms of energy. The potential energy which we calculated in the previous part was 800 joules. So efficiency is given 65. Useful energy output was 800. Input energy we don't know. I'm saying X unknown, multiply by 100. I need this X. I need input energy. So cross multiply. So X will be equal to 800 multiplied by 100 divided by 65. What is the answer for X? It is 1230 joules. 30 or 31, okay. So 1231 joules when I rounded off. But in the question, they did not ask for energy, they're asking for power. So how to this is energy, the input energy. So how I can get the power, how to calculate power?
Work done over time.
Work done over time or energy over time. So energy is 1231. And how much time it took? In the question, the time was given 5.4 second. I just erased just now, but the time was given in the question. That's 5.4 second. So 1231 divided by 5.4. What is the answer here? 1231 divided by, so it is 227.96, which is approximately equal to 228 watts. Is it clear? So we use a formula for efficiency, which is a useful output divided by total input multiplied by 100, and we calculate it. Energy, input energy, and but in the question we need power. So energy is power. Power is energy divided by time. That's why we divided by. From where I got 5.4, that was given in the question. It's given in the question 5.4. And this is a total interrelated. So this was 800 and this one is 5.4. Sorry, 228 watt. In question, in part C, the batteries are recharged. 65 is the efficiency, not the power output. It is efficiency. Useful output is a potential because the machine is lifting the object. So if machine is lifting the object, so output or useful output is potential. Efficiency of the machine or the lifting mechanism is 65%. That's efficiency. In part C, the batteries are recharged with a main voltage supply that is generated in an oil-fired power station. Compared to wind farm, state one advantage and one disadvantage of running a power station using an oil. What is the advantage and what could be a disadvantage? Compared to wind farm power station, they use, so produce a greater amount of energy and it is reliable. You can mention that. And disadvantage, yeah, it pollute the atmosphere or environment. Greenhouse gases are also emitted. That's correct. So running cost is in the in this question, like example, you have a machine. There's a machine. This machine is lifting the object. As this machine is lifting the object to a certain height, it lifts the object to a height of 2.5 meter. So what is the energy it provide? It provide a useful potential energy because it is lifting the object. And this machine or mechanism is 65% efficient. Means what is the input energy? What energy it takes? Only 65% is converted into potential energy and remaining is lost. So you need the input energy. So that's why you use the formula efficiency is a useful output. The output is potential divided by input, which you are finding multiplied by 100. So efficiency of this machine is 65. N is the efficiency. The output, it provide a potential energy. Input, we are finding and multiplied by 100. The potential energy you calculated in the previous part was 800. So you just have to substitute the value 800 here and find the input energy. And after calculating the input energy, you can calculate the input power. So this is a machine which is lifting an object, and it is 65% efficient. Means if we take, like example, 100 joules of energy, only 65 joules of energy is converted as potential, and remaining 35 joule of energy is lost to the surrounding. The next question, the aircraft accelerate from rest along a deck that take off, the aircraft speed is 75. So speed of the aircraft is 75. The speed of the aircraft is 75, and the mass of the aircraft is 9,500 kilogram. You need kinetic energy. How to find kinetic energy? Kinetic energy is half mv square. So 0.5 multiplied by mass of the aircraft, which is 9,500, multiplied by speed, it was 75, and then square. So you'll multiply, what you will get? You will get the kinetic energy. What is the answer here? 0.5 multiplied by 9,500 multiplied by 75 square. So it is, in terms of exponent, 26 exponent 6, I can say. Joules. That's the kinetic energy of the aircraft. Next part, on an aircraft carrier, the catapults provide an accelerating force to accelerate the aircraft. The catapult provide a constant force for a distance of 150 meter. Calculate resultant force. So we need a force as it accelerates. The kinetic energy at a takeoff from a work done on the aircraft by a catapult. What is the meaning here? Look, there's an aircraft or there's a plane, and it is taking off from the ship. Like this is an aircraft carrier. So this is an aircraft carrier which is carrying the aircraft, because aircraft carrier use catapult to provide energy. So example, if there is a plane here at this point, this plane is initially one side, and what happened? This plane is accelerated by a catapult. Means there's a device which is accelerating this plane. So this device accelerates the plane till the last point when it accelerates the plane. So plane will leave this carrier, aircraft carrier or the ship, with a kinetic energy of 26 exponent 6 joules. That's the kinetic energy of this aircraft. So what happened? We need a force. How much force is required? And the distance move from one end to another, that's equal to 150 meter. So the distance is 150 meter. We need a force which is required to move this plane from one place to another. So basically we did a work done. So work done is equals to the kinetic energy. Like example, this is a work done, and that work done is transferred as a kinetic energy of the plane. So you can say work done is equals to force multiplied by distance. So what is the work done on the plane? That all work done is transferred as a kinetic energy. So if kinetic energy is 20 exponent 6, what will be the work done? So work done is also 20 exponent 6. Because like example, if I say I did a work done, I move a plane, I did a work done of 100 joule. So what will be the kinetic energy of the plane? That will also be 100 joule. If I did a work done of, if there is no loss of energy, or if there is no loss or absorb energy, then all of the work done is transferred as a kinetic energy. So the work done by the catapult is same as the kinetic energy of the plane. So work done is 26 exponent 6. Force we don't know, and the distance which we move is equals to 150 meters. So we need a force which is accelerating this plane. So work done divided by distance will get the force. So it is 26 exponent 6 divided by 150. What's the answer? So it will be 180. Yeah, approximately. This is a whole number, but if you round it off, this is the actual answer when you calculate. This is the answer which you calculate. But if I round off, then I can write this as well. But this is right answer, correct answer. Is it clear? This question?
Yes.
So basically there's a work done on the plane, and then work done is changed as a kinetic energy. Okay, question 6. Question 6 can have a detailed answer depending on what you want to write. State the name of the fuel that is burned to produce large amount of electrical energy. Describe the process by which electrical energy is obtained from a chemical energy stored in the fuel. The name of the fuel, you can write any fuel here. It's up to you. The fuel which you burn and produce heat, and then heat energy can be used to produce electricity. So what fuel we use here? Yeah, fossil fuel. And specifically, you can name this fossil fuel. You can mention coal. Here the name of the fuel, you can mention coal, or you can mention oil, or you can mention gas, any one of them. Then description of the process means what happened. So how this process occurred or what happened. So chemical energy of the fuel is released by combustion, changed to heat energy, which is released by burning or combustion. The heat produced absorbed by the water, which turn into steam. The steam rotate turbine, which drives the engine, drives the generator to produce electricity. Is this clear? You cannot write uranium here. Why you cannot write uranium? Because uranium is not burned. In the question, they specify state the name of a fuel that is burned to produce large amount of electricity. So uranium is not a burning, it's a nuclear. If the same question was there, name a fuel which can undergo a nuclear change and produce large amount of energy. In that case, you can mention uranium. But right now in this question, uranium is not a right answer. You can mention any of the fossil fuel. You can mention coal, oil, or gas. Explain why the sun is a source of energy stored in fuel A. Why the sun is the source of energy for coal, oil, and gas. What is the reason why the sun? Basically, it is related to formation of a coal, oil, or gas. So what happened? How this energy is formed? So sun is a energy source for plants and living organism as they grow. But when these plants or animal die or decay, they are compressed to form these fossil fuels. That's why sun is a source of energy. So why the sun is a source of energy stored in the fuel A? Because these plants, most of these fossil fuels are remained of plants and animals. So plants obtain or take energy from sun when it grow, and decay under high pressure, change them to fossil fuel. Yeah, that's right, Afif. I'm not writing the full answer. What you wrote is correct. I'm just explaining the idea. Then explain whether a process is renewable or non-renewable. This process renewable or non-renewable? So it's a non-renewable process because but it is of 2 marks. So you have to mention why it is non-renewable, because a source can not be replenished over a short time. Like it will take more time to form this source back again. So it's not renewable as a fuel is consumed, and can only be replaced over a long time. It cannot be replaced over a short time. Like same amount of coal may form after a long time, not in a short time. solar cell that use radiation from a sun to generate electricity. State the name process which release energy in the sun. How energy is released from the sun? Which process? Nuclear fission or fusion?
Fusion.
Nuclear fusion reaction. And what happened in this nuclear fusion reaction? So you just have to write the definition here, that lighter nuclei join to form heavy nucleus and release energy. Collide or join. Then apart from a solar cell, there are other energy resources used on Earth from which the radiation of sun is a source. State the name of one of these energy resource and explain whether it is renewable. So other than solar energy, what else is there which is derived from the sun? So if you mention fossil fuel, then it will be not renewable, non-renewable. But for example, if a student mention wind here, then it will be renewable. But if student mention, like example, coal, oil or gas, then your answer should be non-renewable. So this answer may vary according to the example which you give. State two advantages and two disadvantages. Geothermal you cannot mention. Reason why you cannot mention geothermal? Geothermal is energy from the core of the earth. So geothermal is not derived by the earth, derived by the sun. Geothermal is actually not from the sun, is not a source of geothermal. But in the question they may mention we need an energy resource for which the sun is a source. So sun is a source for fossil fuel like coal, oil and gas, wind energy, wave energy, solar energy, but not geothermal. Even tidal energy is due to the moon. It's not because of sun. So tidal energy and geothermal energy are renewable, but they are not derived from the sun. It is geothermal is from earth and tidal is because of the gravitational attraction of the moon. Is it clear? Next, state two advantages and two disadvantages of using solar cells to generate electricity. What are the two advantages? Two advantages and two disadvantages of using solar cells. First two advantages. Renewable. So you can mention no pollution or no polluting gases and low maintenance costs, cheap to run, and it is also clean. And disadvantages, so unreliable, expensive to build, and take lot of space to build. Like you need greater space to build these renewable, these solar panels, like placing these panels. And very low output is there, so we have to store the energy. No, it is not polluting the environment because it does not give out any energy, any emission. Like carbon emission is zero for solar cells. Initial cost is higher. Question 8. State the principle of conservation of energy. What is the principle of conservation? Energy cannot be created nor be destroyed, but changes from one form to another. A girl throw a heavy ball. State the energy change that take place from when a girl began to exert a force on the ball until the ball hits the ground and stop moving. So a girl is pushing the ball. So what is the energy change? A girl tried to push the ball. So whenever you are applying a force on anything, so which form of energy is there? Chemical energy. So chemical, gravitational, kinetic, and then basically not chemical to potential. First it should be, because it is at certain height, so it is having a potential. And a girl push, so chemical. So initially the ball is having both the chemical, and it's not like, because the ball is at certain height, so it is having potential energy. A girl is pushing, so she provide an extra energy to the ball. So chemical to potential, or chemical potential to kinetic. And sound you can mention as well. So energy, chemical energy to kinetic to, or potential, or kinetic to potential to kinetic. Anyone you can mention. Heat energy as well you can mention. The next part is related to calculation. A skier taking part in a downhill racing means there's a downhill racing, and a skier is coming down.
Sir, sorry, like
Yes.
in the last question, potential or kinetic was first
No,
after
actually
chemical.
there are variable answers for this question, because it is acceptable if you mention chemical to kinetic to potential, or it is acceptable if you mention chemical to potential to kinetic, or that's also acceptable, chemical to kinetic to thermal or heat. A lot of acceptable answers are given.
Oh, okay.
Like there's no fixed answer, that's why different combinations are there. All are acceptable almost,
So as long as they're correct, like
as
they
long as,
describe the situation.
yes. The mass of a skier include his equipment is 75. In a ski race, the total vertical height is 880 meters. So means he's coming down vertically from a height of 880 meters. Calculate the decrease in gravitational potential energy. So the mass of skier is 75 and he's coming down to ground. To calculate the potential energy, decrease in potential energy, it's mgh. Mass multiplied by gravity multiplied by height. So mass is 75, gravity is 10, and height is 880. What is the answer for this? 75 multiplied by 10 multiplied by 880. So 660,000, or 660 exponent 3. That's the energy which a skier is having at this point, 660,000 joules. But what happened? The skier starts from rest. The total distance traveled by the skier descending is about 2000. This distance which he traveled is 2800 meters. And resistive force is there. There's a force which is opposing his motion. There's a force which tried to stop his motion. That force is 220. What is the work done against the frictional force? So how to calculate work done? Work done is force multiplied by distance. So force is 220 and the distance is 2,800. How much work is done by the skier? 220 multiplied by 2,800. What's the answer for work done? 616,000. So 616,000 is a work done because of resistive force. So whenever you do a work done that again against a resistive force, like example, if I say you have energy of 100 joules, okay? Initially you have chemical energy of 100 joule and you're running, and there's a air resistance, which oppose your motion, and you do a work done against the air resistance, example 80 joules. So how much is the energy left in your body when you reach the finish line? If originally you was having 100 joule, you did a work done of 80 joules. So how much energy will be there you use to run this race? The useful energy, it will only be 20 joules. So same thing happen. We need a kinetic energy as it crosses the finish line. So the skier at the height, he's having 660,000 joules of potential. Because of the air resistance, because of the resistive force, he has to lose its energy. He lost 616,000 joules because of air resistance. How much is the kinetic energy at this point, at a finish line? How I can find how much kinetic energy will be there? Originally, he's having potential. He lost 616,000 because of air resistance or resistive force. How much is the kinetic energy? So how you can find kinetic energy? This was the original energy. This much is lost because of air resistance. So the kinetic energy will be the difference. So if I need a kinetic energy, because the speed is not given. So if the speed is not given, so that's why it is 444,000. Look, he was having, at this point, a skier was having energy of 660,000 joules. That was the energy which he was having at this point. When he's coming down, because the friction is opposing its motion, he lost, because of air resistance and frictional force, he lost 616,000 due to the resistive force. So how much is the energy left at this point? So originally was 660,000. He lost 616,000. So how much is the kinetic energy or energy at this point? That will be the difference. So it will be 44,000 joules. And why he bent his body? So to reduce the air resistance, because when we have small surface area, so we have a lower air resistance. Is it clear now, discussion? Any doubt in this?